So hopefully you've been reading through my article on how to flash the NodeMCU, this little guy here, to work with RGB LED strips. You can see the one behind me. Controllable from Home Assistant. Super cool. So I'm going to try and take you through the steps required to flash the Arduino using the Arduino IDE, the NodeMCU. So let's get started. Now, you're hopefully at this point in the article flashing the NodeMCU, and there's a link here. You can find the code I used on GitHub, which takes you to this repository which I forked from Bruh Automation. And in this file here, you've got everything that you need. So let's go ahead and just copy and paste into the Arduino IDE, which you can download from this website here. It's the arduino.cc main software site. So you can download the Windows, Mac OS or Linux versions. Personally, I'm on Arch, so I just need to install these guys. And that lets me do what I need to do. Now, the next thing you'll need to do is go to the ESP8266 Arduino GitHub repository here. Grab the boards manager link, which is not very far down, about halfway down the page. Grab this link, go to preferences and input this into the additional board manager's URL. So let's do that here. Then next thing we need to do is go into tools and boards manager, and then search for the ESP8266 platform, and we'll install the latest stable version. Great, so that's now done. Next thing we need to do is go and grab a couple of libraries. So if we go to tools and manage libraries, let's go and grab the fast LED library, which is here. I always like to make sure we're on the latest stable version. So let's do this. Now the next one is pub sub client. Here again, we're on a stable version. That's good. Arduino JSON. Okay, bingo. Now this one gave me problems once before, so always make sure you are using the latest stable and not the beta versions. So let's install that. And now we should be good to go. So let's plug in our NodeMCU using a micro USB cable. When you power it on, there should be a little blue light goes flash. That's good, it means it's there. Now, the next thing we need to do is configure our code. So if we look under here, there's a bunch of parameters to fill in. So let's go and fill all of this stuff in. Hopefully you know what this is. If you're running, one quick thing, if you're running the MQTT server as part of Home Assistant in a Docker container, it's likely this IP address will be the IP address of the host that's running the Docker container. So let's just use my junk password. I don't use that for anything important, so don't try. This hopefully gives us everything we need to configure and connect to the MQTT server, as well as configure the Wi-Fi on the NodeMCU. Now let's give the device a name, change the over-the-air password. This is super useful. I'll try and remember to show it to you later. And then these couple of lines are super important. So you're going to have to make sure that you set the topics correctly in both the firmware side, but also on the Home Assistant side. So if we look at the code for Home Assistant for a second, let's look for chimney. So I have a few things in here. State topics is probably it. Yep, there we go. So under here, I have a couple of topics that I am subscribing to and publishing to, and those are here. Now these must match these here. So LED/chimney, LED/chimney/set must match exactly in between the quotes what's highlighted there. If it doesn't match to the character, it just won't work. So it's, you want to watch that. You also want to make sure that there's only one well, you want to make sure there's only one NodeMCU subscribed to the same topic. Now you could subscribe multiple to the same topic, but just remember, if you send a power off command to that topic, it would turn off all 4 strips all at once. Now, using Home Assistant, it would probably be a better idea to group the lights together using the light group function that Home Assistant has, rather than using the same topic for multiple devices. That's probably the way I'd do it. So right now we have in here everything's set correctly, I believe. We have all of this stuff set. We've made sure that our LED count is correct. So this strip behind me has 300 LEDs. This is the chipset that's being used as well. There's a few other things we can configure, like max brightness and some of the RGB values, but generally speaking, it's just this sort of from here upwards that we want to use. So once we have everything ready to go, we then need to go to Tools and select under Board if you haven't already, which out of the box it would come like this, Arduino Yun maybe. Scroll down to here and find NodeMCU 1.0 ESP12E module, select that, and we have our Arduino plugged in, and it's available on dev TTY USB. Now for Arch users, there are a couple of things to be aware of. You're going to need to make sure that your user is in the correct groups to access via serial. Windows and Mac, security is not important, so you can just do it. Add your users as per the Arch Wiki article. So once that's done, we have everything ready to go, I think. So we need to make sure the upload speed is set, that all of this other stuff matches. Just pause the video and take a look. And then what we can do is just click upload. Save sketch to desktop as, that's fine. All right, so what it's doing now is it's going to compile the sketch, and then it's going to upload it to the NodeMCU, and you'll see that this LED starts to flash, and that goes in conjunction with the serial console at the bottom. Once that is finished uploading, the little blue light will stop flashing. I'll just hold this up here whilst it flashes. Doesn't take very long, maybe 15-20 seconds or something. And then the board will reboot, and that's it. So how do we know it works? Okay, so we go to Tools, and do not unplug at this point. We go to Tools and go to Serial Monitor, and then if we head over to Home Assistant, now this is assuming you've got your Home Assistant set up. You should be able to just click on this button here. Do I have the board set correctly? No, I don't. Let's try that again. See these ... I wonder what that means. That must mean I've done something wrong, or maybe it's not connected to my Wi-Fi or something.
A few moments later.
I got the Wi-Fi password wrong. So let's in my Unify, I thought I'd put example password. I put example key. So just show you how easy it is to go and change. I'll just change that. Press save. Control S, but I suppose you can go the old way and do it here. And then just click upload again. I didn't close the serial monitor this time, and apparently it worked this time. So such is life as an Arduino programmer. Apparently serial devices are unpredictable. Still flashing. Still flashing. This video was supposed to show you how easy it is. I think it's possibly taken a little longer than I thought I might. Okay, connecting to example. There we go. Right, so that's what it's supposed to look like. Okay, so this was a brand new, fresh out the box NodeMCU. So now let's go back to Home Assistant and we'll see here we have our messages coming in. Currently, it tried to connect to MQTT and connected just fine. So let's do a chimney LED strip, turn on, message arrived. Here we go. And here's the JSON payload, state on, chimney LED strip off. Brilliant. So in here, let's change the RGB values. And you can see as I drag this slider around, the RGB values here change. And let's change the effect to police. And so based on what's in the firmware, you can see that this little guy here is, so let's just go take a look at that, for example. So police, effect police all. So if effect string equals police all, that means it's going to do what's here. So if you want to create your own effects, this is how you would do that. You would base it off of this portion in the code here. But that's pretty much it. I made it look a lot harder than it was, but these things do go wrong on occasion, so it's good to understand how to troubleshoot. So yeah, I hope you got something out of this article, and I wish you all the best with your Home Assistant and NodeMCU LED journey.